Okay, our last session today is going to be a panel discussion, which is on the 3 R's of infrastructure: reliability, redundancy, and maybe most importantly, resiliency. How do we come back when an event happens? I'm pleased to announce that all the people in this panel are New Tech Group employees, so they represent a lot of our vast years of experience in manufacturing. The moderator for this session will be Dave Atkins. He has over 20 years of experience in structural engineering and project management, and he is our Executive Vice President and Director of Operations at New Tech Design. Working from closest to me to farthest away, Jeff Pauley. Jeff Pauley is a Vice President with JDB Engineering. He has over 30 years of experience in HVAC, systems, and process engineering. He's a registered mechanical engineer and is a key lead on many of our technical projects. In the center is Craig Malesic. Craig comes to us after running his own electrical contracting company. He has certifications in communications, and he is a PMP certified as well. And he's an EIT of electrical engineering, and to his credit, he's running an electrical engineering company and realized he wanted to come back and get his professional licensure, and he's been a great addition to our team with real-world field experience. And then lastly, speaking of real-world field experience, is Steve Krone. Steve has over 45 years of experience in manufacturing and industry. He has an electrical engineering degree from Penn State and an MBA from Purdue. Before joining us, Steve was U.S. Operations Director for Maintenance and Process for Caterpillar. So at some points we may have to cut Steve off because he has so much knowledge in his head that he wants to burst out. So at some point, if we do that and he's on a good train of thought with you, catch up with him afterwards. Okay, with that, I'll turn it over to Dave.
Thank you, Andy. Good afternoon. Hopefully everyone has enough sugar in them. Keep us interested. There's been a lot of conversation this morning, a lot of information being thrown around, so we just kind of want to have a little bit of a brainstorming session that we just kind of, some of our experiences and share our thoughts in the process of the IT. So, first question, we want to go to Craig. Okay. Mike touched on this during his presentation as far as some of the older equipment that's in facilities and trying to maybe kind of how to tap into some of that with the infrastructure. Could you go into a little bit of description of IT infrastructure, what you see?
As we're dealing with the Internet of Things, we obviously need to be able to connect to the Internet. So we really need to look at our entire infrastructure, not only what's installed in our plants now, but also our cable pathways, but really look at a holistic approach. So we need to make sure that we're using the right network cable. As we put more and more data on things, we probably want to upgrade. If we have more legacy type cable, we want to make sure that we have the correct amount of server spaces. So if you're in an older facility that doesn't really need that, do you have places to be able to connect all of your racks, your servers, your equipment? Is it properly ventilated? Is it properly cooled? Do you have the pathways to get out? And what does your wireless infrastructure look like? Obviously, if you just have a single Wi-Fi point, somewhere in the corner of a facility, you're not going to grab all of your sensors. And then also, what is coming into your plant? If we're going to be putting stuff up on the cloud, are we going to be connecting to our facility from external sources? We need to make sure that we have those pathways, with the right type of utilities coming into our plants. And then it goes beyond that with your IT folks. What are your policies and procedures with iPads, tablets, phones? Is you have a common theory of how you do things, or are you just a hodgepodge of devices that it becomes a nightmare to try to remotely connect to things? And so it's really looking at all of this as a holistic approach.
Let me just add to that also from what I've seen from years of various projects on different plants. It's really the advent of the Ethernet and the internet that's really enabled us to do all the wonderful things we've been talking about today, because plants used to be set up that you had a single communication link that was just HVAC equipment, one was just process equipment, and then one that was set up just for your business functions. But because the advent of the internet and that the business functions seemed to be the one that really drove the Ethernet development, then what I saw frequently after that was then the HVAC component started to say, hey, we can ride on the same highway, same with the process equipment, we can ride on the same highway. So a lot of that kind of enables this data sharing that we're talking about. And then to take it one step further, the whole wireless revolution is probably going to take it to the next level as well.
Do you find that if I walk through my plant, there's all these gizmos that have Wi-Fi printers and stuff like that? Do you find that they completely interfere with each other at all, or is that something that's relatively clean with the protocols that we have now?
With the way the protocols work, they won't have interference, like if you're thinking like radio interference, but you also have to look at the throughput of what it is. So if you have a lot of data that is critical, and so it's like a high data usage, so if you have a marketing department that's on that network that's dealing with videos or photographs, you might want to literally have separate networks and separate Wi-Fi's, or you might actually want to, there's equipment out there that allows you to have one physical box that's in the ceiling, or multiple Wi-Fi points, but they're really on separate data networks. Okay. And so it's not so much that you have interference as, like when you, if you remember driving with AM, that one station would come into the other, because the digital communication prevents that all from happening. But what you do have is, do you have enough capacity? So think of a highway and how busy it gets during rush hour traffic. You might need multiple highways or multiple lanes, something that allows it to do. So that's really where it comes down to, is separating those systems possibly, or running it and separating it more in software.
And then security concerns come into play too, because I know when HVAC initially got piggybacked into the business, the business IT people were real resistant to it because it was basically theirs. So to open that up and have the right protocols and have the right security features in your system, I think is very important, something to look at as well.
And Jeff, you just brought something up about software. And we've heard that a couple times throughout the conversations today about software integration. Can you elaborate some of your experiences with software in facilities?
Yeah. Specifically, what I've seen is several different platforms, and it's the interoperability or the communication between various platforms that's been kind of difficult. As you guys probably know, in the PLC, it's been traditionally Allen Bradley, Siemens, and those are the major guys. But now you have a lot more developers and a lot more people that are getting in the mix. On the HVAC side, at one point it was just you had your Honeywell, Johnson Controls, and a few others. They kind of controlled the whole industry, but then what happened is protocols started opening up. You saw a lot more secondary providers start coming in, Automated Logic, Novak, a couple other ones that kind of use the same functional features, but in a more open protocol. And I think that's important also for the development of all the things we've been talking about today, and that's developing a standard that everybody's communicating and linked in together. And that's what really promoted it and really got it moving with some thrust in the HVAC industry. There were a couple open protocols developed, LawnWorks and BACnet. Of course, BACnet became the prevalent open protocol in HVAC. But once that was taken off, all the vendors, all the sensor companies, everybody got on board and adhered to that standard, which enabled interoperability to really take off. And I think that same standard needs to be developed in industry communications, so that you buy one piece of equipment from one company, one sensor from another company, it's easy to translate from one to the other and have them communicate to each other.
That was the development of that protocol in the HVAC easier because of it's in not obviously in a small industry, but a small subset where they were able. You have less players, I would imagine, in that game than some of the other.
Yeah, so I really have real questions in my mind as to what agency or what group or what company is going to be the driver for the interoperability in industry. Who's really going to push it? Is it going to be executives? Is it going to be end users? Is it going to be equipment, providers? Is it going to be your sensor and system developers? At this point, I don't know, which one's going to have the biggest thrust. I know in the HVAC industry, it became LawnWorks, who was very profit driven, versus BACnet, which was very academic driven. I was really kind of surprised that the academic won out in that case, that everybody followed that protocol, but I think it was more because of ease of use than anything.
And I think a lot of times you see it in the standards organizations. In lighting, there's a big push right now because of LEDs, but it's integrating sensors into every single light fixture. And so IEEE, which is the International I forget what it stands for, it's Electrical Engineering Standards Organization, and they are redoing their Power over Ethernet protocol because lighting manufacturers want to power lights over your data cabling. And so typically that protocol was run by your computer industry, and now you have these other industries getting. So I think you'll see a lot of standards organizations fighting to be superior, and we just need to see who wins.
So there's a lot of communications going on, and I see it very interesting. Steve, you've been around this industry for quite some time.
All of your.
Yeah. And communication from a maintenance standpoint used to be going out to a gentleman who had years of experience working on the same piece of equipment. How do you see that kind of changing as we move forward in the future?
Well, one thing I want to recognize Mike here for the fact that he talked about so much of what's happening out there in the real world. When you think about communication in the future for maintenance, it's really about a tablet. How are they going to get the safest working conditions that they don't get injured? So they're going to get that information right in front of them when they go to do the work order. They're going to have all the latest documentation. They're going to have capability of OEM communication. You know, I think Mike talked about KCF there and how they monitor his transmitter devices. Most of the big companies, especially Ingersoll, who's building big machine tools, they have a 24-hour service of an OEM technical service group. So the maintenance guy can actually talk and audio, video in front of him as he's working on the machine. So the whole concept of training maintenance people on memory of how to fix a machine is going to be different in the future. It's going to be all digitized. It's going to be all digital. That's the new wave that's coming forward. And if you think about it, all of us, or certainly I do at my age, go to the doctors. Did you happen to notice that doctors are carrying laptops around with them now? All your data for your medical information is right with you. They're actually using those tools today. You look at your IT people. All your IT people carry tablets or a smartphone.
I think that's a good point, Steve, and I think it's really, kind of shows the culture change in the U.S. and across the world globally, in that now, I remember going through various different plants, and there's always in every plant that guy. It's that guy. He knows how to fix every machine. He knows, he can see by something bobbing up and down that that machine's about ready to fail. He has that knowledge in his head. He has the ability to fix it. But how do we share that knowledge from that guy to, you know, your other plants, you know, and that sort of thing, and also to train young people coming in? Because, quite frankly, because of the culture change now, you're going to have young people coming in with their iPads and their iPhones, and they're going to say, "Oh, wait a second, you want me to use that wrench to fix that?" No, you know. They're going to expect coming into your place that you're already up to speed on technology, especially if they're coming, you know, right out of college. They've been using it their whole lives. Now they're into the workforce. One other thing that I wanted to mention about that is with that guy is with transferring the type of data that Mike particularly showed us. That translates from plant to plant a lot easier than, well, you got to send so-and-so to Kansas City so he can show them what you're doing here and make sure that it's done the same way. So there's really some, you know, efficiencies there that can be gained in the future, especially in the maintenance planning field.
If I can add to that, Jeff, think about 10 to 20 years ago, everybody had apprenticeship programs. They had new hire in the maintenance group, and they would work with the older gentlemen who used most of the time their memory repair the equipment. The equipment today is getting too sophisticated. Memory's not working anymore. Doesn't mean we won't use our past experiences. It simply means in order for us to troubleshoot the equipment faster and get it back online, we're going to have better tools. And that's where IoT really helps you, so that you can get the equipment fixed faster. Mike used the word predictive maintenance. I have a little different word, it's called anticipation. What you don't want to do is let the equipment break down. You want to find out before it breaks down. Anticipate the failure. And that's really when you look forward to maintenance and where it's going to be at, is you got to think about the old way of training people is not going to work for the future. It's going to be digital information. And how do you give them that tool so it's right there in their lap as they're working on the equipment?
Yeah, that's information that basically we're relying on information. Correct. So I'm going to go with Craig. There's so much information that being collected. How are you going to kind of manage? What steps should you kind of put in place? How do you really want to see this information displayed to your maintenance people, to have it interact with multiple sites? Let me leave it at that.
Well, I think that as the younger people come in, they will demand to have instant access to all the information, from manuals to history, all that kind of stuff. I mean, it's the type of thing, if you remember, you used to sit around the table and say, who was that actor that was in that movie? And then like 3 days later, you're like, oh, I remember, it was Dustin Hoffman. Well, we look it up instantly now because we expect to have that information instantly. It's instant gratification. Well, the same people expect to have that information that I'm not going to walk to, where we keep our manuals and get a paper book. I have my phone with me. I should be able to bring that up. And so, using the cloud-based services or internal networks that have all this information, but it's really coming down to dashboards and also modeling. So in the design world, a big thing is building, or BIM, or building information modeling. And from a designer, we really work on the building modeling, or how things physically interact. So when we coordinate and we have a ductwork and a sprinkler pipe, they're not running through each other. But from the facilities point of view, it's really the eye, it's the information. And so being able to take and build a model, because that's the plant that we're in. When we're standing there, we're saying that machine there, or that piece of mechanical equipment on the roof, and be able to look at that model in the video game world, which is what has really, people play video games in 3D. We can look at a model of our plant, we can say this rooftop unit, click on it and get that information. We can bring up the associated manuals, tie into our facilities management databases to look at this IoT data, the history, the breakdowns, look at our parts, and really start to understand how that piece of equipment interacts with other things. So we're not just looking at a mechanical piece of equipment, but it has gas piping, it has drainage to it, it has an electrical circuit. I can't tell you how many facilities I've been in that nothing's labeled electrically. All we know is it works, and if we somehow trip the breaker, we can figure out maybe, or there's one plant guy that knows where it is, and you go to the panels and it's masking tape and pencil labeling it. And being able to have a model that you can actually look, click on it, say it's panel such and such, circuit 1, 2, and 3. It's really starting to realize that and tying it into almost a video game type world, tying this data, tying these sensors, and really starting to connect all of that so we have instant access, from our mobile device.
If I could add to that, you just talked about the information. When the design is created in BIM, it has a tremendous amount of data behind it. It has all the motor sides, the current flows of the devices, maybe the airflow of the fan. All that is automatically dumped into your CMMS system. You don't have people putting that data in by hand. We all know about the fat fingers, errors, but all your data that's, when the design's really put there in the front end, there's nothing physically in front of us. That all gets transferred into your computer system, your CMMS system. And so there's a tremendous amount of history now that's not lost. All of us can think back and say, oh yeah, I remember we built that building or bought that machine 15 years ago, but I don't know where the manuals are at.
Even with the example that Craig gave there, you know, I can tell you examples of the same thing. We need to shut down a piece of equipment, nobody knew where the breaker was. So it's like, you know, have all the maintenance, or not maintenance, but repair people there on site, you know, waiting an hour until somebody figures out how to shut a piece of machinery off. If you have that information, I think that enables you to get, you know, the right information to the right people at the right time. They can take care of the problem quickly.
I just like to add something as I was hearing you guys talk. Everything has a process. Most processes are broken. So my caution to all of you is if you have a manual process somewhere in your facility and you're automating a manual process, the thinking is that as soon as I automate it, it's going to be instantly better. I've seen far too many times where you take a broken, crappy manual process and you automate it, you know what you get? Automatic crap. I've seen it far too many times. So if you have a manual process that you're automating, make sure that your manual process works well, you remove the waste out of that manual process, you improve the validity of the data that goes into it, you take all these other things into consideration before you automate it, because you will not get better.
Well, I think to that,
And I want to say that he's exactly right. Simplicity is the key word there. Don't think by automating it that it automatically works. You can make it so complex nobody will use it, right? So keep it simple. It doesn't have to be complex. You can automate a lot of things and keep it simple. And Mike showed us those transmitters. That is something that's really simple, right? It's a magnetic device that attaches to the point where you think can be your failure. You don't have to do complex things to make the results positive, and yet take out the guesswork of maintenance people telling you from their memory, oh, I think that thing over there broke. It breaks about every year. And that's really what we're trying to get to in the next generation of maintenance.
Yeah, I agree. It needs, for the technology to be effective, it has to, in the end, be easier to use than it was before. And I know just that example of the sensors that Mike had brought up, it's a good way to get started in this simple way. Look at your simple task. Don't get overwhelmed and thinking, oh, I got to have all this information connected to the Internet of Things, or, you know, I'm not going to get the results that I want to see. I think you really need to get over that initial inertia and fear of the high capital costs it's going to take to get into this by starting small, those things that are simple to take care of.
yeah, I think Andy had used the term, I don't know how many people know agile project management, but it's a slow, iterative process to get from point A to point B. And so I think we've talked about planning. The first speaker talked about you have to have a plan. And so I think that you need to envision what you would like your facility to look like and say, I want to have everything connected. I want to have all this data. It's all going to be automated. And that's the utopia of what we're trying to accomplish. But then you step back and you say, what am I going to do tomorrow? Well, you decide what your low-hanging fruit is. And you say, I'm going to try this one problem. That's my biggest problem. How can I use all this new stuff that I'm learning about to solve that one problem? And you're thinking about how that fits into where you want to be in 3 years, 5 years, 10 years, depending on how aggressive you are. But right now you're just trying to solve that one little problem, small project. You know, you need wireless, but you only need wireless above that one piece. You only in your whole plant, you need one data cable, one wireless access point, because you have one sensor or whatever it is. And so once you do that and you prove that, you also get you know, proof of concept and financial backing. You go, hey, that was really good. And somebody says, well, let's try that over here. And you can start to scale it and start to build it. And, you know, it's the type of thing that, you know, eventually you'll get to the point that in small pieces you've done 80%, and now you can say, hey, let's do the last 20% as a big project, and everybody's behind it because you've proven it on that first 80%. So you don't have to do everything.
Yeah, I think, you know, that goes back to being reliable system, and a good upfront program in place to understand what's going on. Jeff, with your work, that you've seen some of this actually working hands-on with some clients. What type of systems are they monitoring? Can you share that? And the information that they're getting back and how they're implementing it in their maintenance program.
Yeah, I mean, a lot of what I'm seeing is some of the things that are mentioned today, temperature sensors, vibration sensors. I deal more with a lot more like pressure, humidity, flow, those types of things as well, which gets a little more complicated, but there's a wide variety. You start looking at stuff available sensors out there. I think the challenge for you guys is to pick the ones that are going to be the ones that are going to prove to be effective for you, but also enable you to tie in to these other systems at some point. We mentioned as to who was going to be the driver of this whole Internet of Things in Industry 4.0. Part of it's going to have to come from the equipment suppliers. You know, people who build the sensors, people who have the equipment. They're integrating that technology so that you have it in a lot of cases when you have the capital to do a new project, you get it then with that equipment for that particular project. Now you got to start. So that's mainly where I've been seeing this technology get integrated into existing plants. It's usually as an adjunct or an added premium to a capital project that's already been, awarded or under consideration already.
Did I say hand over there? No. So, Steve, we're seeing a transition of maintenance with the staffing situation. I mean, we've talked about it here a little bit. Talked about trying to get that information out of the senior representatives in the facility, coming into a newer generation. The Internet of Things has communication, has all those links together. Mobile devices is going to be a key role. This younger generation wants to be mobile. Your experience seeing maintenance individuals, how's that relationship, how's that cultural change going to come about?
Well, obviously, the younger generation loves the digital world, and they want information instantaneous, confirmed. They really don't want the manuals. I think someone already said that. They don't want to look at drawings. They want to see it on a digitizer. They can get it instantaneously. That's the transformation that's going to happen in maintenance, and we have to be ready for it. The older guys like me that had it from memory, a lot of the equipment. You cannot afford anymore to have the apprenticeship programs or the training programs that take 1, 2, 5, 10 years for a person to meet your needs on the facility floor. You have to really break that down to about 3 months, 2 months, because you want that person to support you as you have more predictive maintenance workloads. And that's really the key to reliability. We have to move towards the digital world. Doesn't mean it has to be fancy. You don't have to buy super high-tech devices for them. But the new people coming in, the younger generation, I want to call them the Generation X or Y, they're going to ask you where your digital communication's at, your connectivity. I don't want to, you talk about parts. I know there was some conversation there about maintenance parts and cribs. There's all kind of availability out there for you to actually not store parts with vendors. Grainger does a lot. There's a whole lot of companies, Hagemeyer, others, who do what I want to call durable, replaceable items for you locally. But when we talk about the big hardware, whether it's electronic or motors, devices that are usually $5,000–$10,000 a piece. There's other methods of actually leasing them now. And we did some things already where we leased $100,000 parts to a new machine tool for 3 years. Essentially, it costs you about 1 to 1.5% of the value that you want to put in the crib. You have accessibility to it immediately or within less than 2 hours, and you don't own the parts. I'm sure Mike back here is always watching the crib inventory levels, because that actually, not only do you have to purchase the parts at an expense, corporate charges you capital or interest for you to have that inventory there, and so does the government. It's why so many times in maintenance, if you don't use the part once in 3 years, you go to get it out of the crib and it's gone. They had to throw it out because you're already at probably 1/4 of the price of what you pay for the device in the crib. Turns ratio is really important to cribs. So all these things with cribs, communication, finding out there's parts in the crib, they aren't, you don't have to ride there in a scooter. These are all things that are going to happen to us in the maintenance world. We have to somehow get ready for that in order to keep the equipment running.
Yeah, Steve, you pull out a point there. With redundancy of parts, reliability, knowing when maintenance is going down. Craig, I think you have a little bit of experience of this nature with your electrical contracting company. Redundancy. You have vendors. You were asked to have products being supplied. What was your experience as far as if that vendor wasn't able to produce? What did you have backup plans? How did you create that level of redundancy?
I think it's like everything. You establish your preferred providers, the people that you create strategic alliances with. So I had an electrical distributor that they pretty much would bend over backwards for me because of the amount of volume of business that I did. And so as long as they could get it to happen, they would get it to happen. But I couldn't rely on them all the time. And so I had to develop relationships with other vendors as well as to be competitive when we bid on a project, and also to be a backup to that. And so I think it was alluded to before, sometimes you don't have that option, but you need to have that redundancy so that, when one person can't deliver on what there is, you can go to your backup plan. And the backup plan wasn't always the best because I didn't like their equipment or didn't like their brand, or they didn't do things the way I wanted it to do, but at least had something that I could deliver to my clients and get whatever project I had done. So,
And with the Internet of Things and communication, data being collected, how will a relationship work with multiple vendors from a maintenance standpoint? Using a dashboard per se, information will be supplied to them that they'd be able to make adjustments at vendor A, B, or C. Would you be able to expand upon that?
yeah, there's even vendors, in small electrical distributors, there's programs being pushed out because of how accessible inventory and all that is that you can define your own dashboards that are in their world. And so they actually create an inventory that is your inventory. It's not everything they have, it's the stuff that you care about. And so you have 24-hour access via the internet to go in, look at what they have that's your parts list, your inventory, be able to order that and have that ready, in my case, when they open, since they're not a 24-hour operation. And so that kind of stuff is creeping in, and these are distributors that aren't necessarily that sophisticated. So the fact that that is starting to creep in at that level, the more sophisticated suppliers are starting to, or probably have done this and pushing it. And so it just gives that operation that we're slowly moving towards a digital age. And so you're going to have some people that, are slow to react, but there's also your demands. If you buy a high volume of stuff, you might be able to say, this is what needs to happen for us to continue to work with you. We're going to work with this company because they deliver these things.
So a lot of great ideas, as well as just trying to hone them down into what we need to do. And so, Jeff, in the next 3 to 5 years, as the technology becomes more advanced, the information is more obtainable, what role do you see, as we have multiple vendors available to us from a maintenance standpoint, software vendors are going to be coming in and doing controls and helping along with that. The interaction between all three, and how's that kind of honed down on the workforce inside the facility?
Sure, I understood your question. Could you kind
Yeah.
of restate that a little bit?
Yeah, I guess maybe
What do you
maybe
see in the next 3 to
in the
5
next 3
years?
to 5 years, with all the information coming from vendors, from software, from maintenance standpoint, kind of merging those together. Maybe even Steve can kind of allude to that too.
I think we already talked about some of the things, in that you are not going to require to have your inventory in your plant, and talk about redundancy a little bit, and with this interoperability and that predicting failures and so forth, you won't necessarily need your redundant systems like you used to have in your plant as well, if you could react fast enough to get your plant up and running. How software developers come into it is basically going to be, they're the ones that are really going to offer you guys the platforms to take advantage of all this technology. And I just see, you know, you have your major players, but you got a lot of small companies too that are developing technology for specific applications. You got to kind of take advantage of everything and evaluate everything that's out there.
In that evaluation, back to Craig, it's all artificial intelligence, right? We have a grid, we have a network that's collecting that data. If that data is somehow lost through security, what safe points do we have that we can possibly put in place to make a redundant system, so that if we see a breach, that we're able to get the plant up and operational?
I think a lot of it is using cloud computing. So we always talk about the cloud as this ethereal type things. There's even kind of humorous commercials, you know, people storing stuff up in balloons. And in reality, we just got to look at the cloud it's a series, it's a data farm or a data server room that's not necessarily where you are. So if you have 5 facilities and all of your information is in facility A and you all connect into it, essentially you own your own cloud. You know, it doesn't have to be this other thing. So literally when we talk about Amazon Web Services or Microsoft's version, it's just a room or multiple rooms with huge amounts of data and servers and all of that in it that you're connecting into it. And you're paying them to run that facility. The benefit of doing that versus owning your own facility is that you're limited of how much you're going to do. How much backup are you going to have? Are you going to have redundancy? You know, if you have servers, do you have a backup server? Do you have backup power? These companies this is what their entire business model is. So when their cloud service goes down, they lose millions, if not billions of dollars. And so they make sure these things are hardened. They're backing it up. They're not only just backing it up in the same facility, but they literally copy data to multiple parts of the country. So if they have a facility that's in the path of the hurricane, your data is copied somewhere else in the Midwest as well. And so that's their entire business model. So the benefit of using the cloud services is you're gaining the high level of intelligence of people, making sure that it is reliable, it's backed up, that there's power backup type things. And so the only real challenge you have is your ability to connect to it. And so if you have a natural event that affects the lines that come in and out of your building, you can no longer connect that data, whereas if you had your own data center in your building and you had a backup generator, you have access to it. So you have to think about those challenges, but even then you can mirror data, meaning that it exists in the cloud, but in real time you're creating a copy on site. And so there shouldn't be, you're doing things correctly, there shouldn't be a point where you actually lose your data. It exists, it's accessible, it's just not necessarily accessible usually instantaneously, but in the worst case scenario, it might take you a little bit to get it back.
We're so used to an instantaneous world, right?
Yeah.
I'd ask, is there any questions going on in anybody's mind that they're thinking of in their facility that they would like to ask the panel?
I kind of have a question that I'd like to throw out to everybody, just based on what Craig had said. You know, cloud computing and the whole security issue. What are companies feeling about the Internet of Things and data sharing between companies? Is that something that you all can see happening in the future to help each other out? But it's such a competitive market with everybody having their own proprietary way of doing things. I kind of see it as maybe a hindrance to open data sharing across the Internet of Things. I just throw it out there from what you've seen in your companies.
We're part of a larger corporation. One of those divisions is defense-based. So even though we don't play in that arena in our portion of the corporation, we have to abide by the same rules. So data sharing.
So across the board, it's all very private.
All very private.
We, at ESOB, we're using Fastenal a lot though, and so we have an open inventory with them. And one of our considerations is that they won't track just the inventory that they provide us. We might open our entire tool crib to them so they could track our entire inventory, not just of the parts that we're supplying.
Actually, it's a good idea. Think about this in the big picture. When a supplier is totally focused on a particular facet, and that is crib inventory control, right? They're going to manage that a lot better than most manufacturing facilities do, simply because they have 2 or 3 people in there who really only hand parts out. Okay, there's got to be somewhere back here analyzing the turns ratio, all right? The other thing is, again, we talk about spare parts and maintenance. There's just so many options out there now where the high-ticket items, some other person can own it. And think about this on new equipment. You get a $200,000 piece of equipment, $1 million piece of equipment. They're going to give you a parts list of probably $50,000, all right? Did you ever realize if you put all that in the crib, you're lucky to use $5,000 in them parts? So what do you do, guys? You don't buy those parts. You tell that vendor, when you originally purchased the machine, you supply the parts. At the end of 3 years, the ones I use regular, that I notice that machine needs to function, I'll buy them, and the rest are theirs. Every piece of a machine, and I hope Mike can back me up to this, is different. You can't write, even with 2 pieces of equipment that are identical from the same supplier, you're running a different process probably on those 2 different machines, or same machines. So the PMs on each one of those machines are different. They're not the same. When you start talking about conditioning-based PMs and maintenance, it's what you run product-wise on that machine. It's not the machine. That's how you have to develop your PMs. You can't develop them on time. You just can't do it because you can't afford it anymore. And think about this. For us guys that have been around maintenance too many years, if you send a maintenance person out to work, to do a PM on a machine, and you give him the instructions, 3rd to 4th time that he doesn't find anything wrong, guess what he does the next time he gets the PM? He pencil whips it. And you don't even get inspection of that machine anymore. Okay, so it's so critical to do conditioning-based monitoring. Use the tools that are out there electronically today because they're so cheap. They're simplistic. They're not these big systems. People come in and want to sell you $100,000 systems. Tell them you'll take it under advisement because you can get a lot lower cost and get what you want to achieve, and that is uptime, reliability, resilience. The tools are out there today, and we're going to get there in the next 10 years anyway. It's easier to start in steps than it is try to jump the stair steps. All right.
I think that's a great closing thought.